learned that when electric dipole placed in an electric field along the same direction of field, no torque will act on it. Further, it also found that in a uniform electric field, total force also is zero. So some question may arise in some critical situation. You may be asked when an electric dipole is placed in a uniform electric field, whether the torque is maximum, minimum, and total force is acting with some specific value or not. Our answer will be that under this condition, if electric dipole placed parallel to the electric field, no torque will act on it. Moreover, total force, net force acting on the electric dipole will be zero. This is the first test already we have discussed. In the second case, if theta is equal to 90 degree, if theta is 90 degree, that means electric dipole is under the situation that it is perpendicular to the electric field. It is perpendicular to the electric field. Then what happens? Let me see. From this expression one, what gives? P is sine of 90 degree. Sine of 90 degree means 1. That means acting torque of the electric dipole tau is equal to P into E. Okay? That is the product of two quantities, P and E. Obviously, it is a maximum. Maximum value. So this is maximum. Okay? So torque acting on the electric dipole will be maximum under the situation that when the dipole is kept perpendicular to the electric field. Okay? So this is the expression. Why it is maximum? When a quantity is called a maximum, product of two or more. Product of two or more, it gives the maximum. Okay? So this is the maximum. So can you memorize that what happens for maximum value and what happens for minimum value? Can you tell me? Can you tell me? Anybody? When minimum torque is acting on the electric dipole, under what situation? Parallel to the direction of electric field. That is acting torque is 0. When net force acting on the electric dipole is 0, what is the situation? What is the basic condition? That net force is 0. That means electric dipole is to be placed in a uniform electric field. Okay? Force and torques are different things. Okay? As earlier I told you that torque is the rotational force. Okay? Force is the force, the internal motion. Okay? So this is the case. And third case, let me discuss. Number 3. If theta is equal to 180 degree, if theta is equal to 180 degree, that means electric field is acting right direction and torque is acting left direction. Okay? Under this condition, angle between them will be theta is equal to 180 degree. Then what happens? From the expression, you can grab this quantity. So put the value tau. Tau is how much? PE sine of 180 degree. Sine of 180 degree how much? Find the true value. What is the value of sine of 180 degree? of 180 degree. I think you have advanced mathematics in mathematics in associate exam. You have qualified with advanced mathematics. You can divide this 180 degree, sine of 180 degree, sine of 90 plus 90. Okay? So this is converted to cos, cos 90. Cos 90 how much? 0. Then it again becomes, so it is a 0. So again it becomes tau is equal to 0. Tau is equal to. So this is the case when the electric field is acting right direction and torque is acting left direction, angle between them is 180 degree. Then acting torque on the dipole will again be 0. This is also minimum value. So this is the two cases having minimum value of torque on the electric dipole. One position is when electric dipole is kept parallel to the electric field. This is the number case 1. Okay? And case number 2, again, when electric dipole is kept in such a way that electric field is acting opposite to the direction of the torque. Not torque. Electric field. Electric field is opposite to the electric dipole. Then angle between them is 180 degree. Under this condition also it becomes 0. So there are 3 cases. One value for maximum torque and 2 values for minimum value of torque. So these are the 5 special cases elaborating on the acting of torque for a electric dipole placed in a uniform electric field. In the next class, we shall discuss about the case when electric dipole is placed in non-uniform electric field. Okay? In first case, that is in uniform electric field, we have discussed about the acting torque and forces are different. But forces are 0. But in case of non-uniform electric field, if electric dipole is placed, you will get that the net force will not 0. Net force will not 0. So in some examination, you may have such question, multiple choice. How many? Suppose you are asked, under what condition net force is acting 0 due to electric dipole? Number 1, in a uniform electric field. Number 2, non-uniform electric field. Number 3, none of the above. Which one correct? In a uniform electric field. In some question, you may have such type that when an electric dipole is placed in a non-uniform electric field, you may have that the net total force is not 0. That is the case, the field should be non-uniform. Okay? So thank you for today.